11.1, we're dealing with correlation and regression. Basically, we try to, our goal in chapter 11 is, if we have a data, how can we know what is the relationship between the two data that we have? Okay, so in 11.1, we will do a correlation, which basically, again, as you can see, the correlation is basically we want to measure the direction and the strength of linear relationship between two variables, between the x and y in most case, which is, again, that's your odd and pair, or between, you know, the age and the height, or whatever the data that you have. You're trying to compare do they have any relationship between the age versus the height, right? As you get older, do you get taller or something in that nature? Okay, so again, for us, given the x and y, the x will be your independent variable, meaning, again, the x, you can choose any number that you want, and the y will be your dependent variable, meaning it's depend on the x, which is later on you will see the correlation between the x and y, or what do we need to do in terms of that. So one way that we can test the correlation is our eye test, right? Meaning, if you look at the scatter plot, right? If you look at the scatter plot and you can see, you know, the direction of your data, does the data from left to right, does the data increasing or does the data decreasing? Or pretty much, does all of your data follow the straight line? If it's a straight line, we say it's a linear correlation. If they don't have a straight line, if it's all scattered, we say a weak linear correlation, or no correlation at all. Okay, so again, most of the time in the beginning, we will basically do the scatter plot, and then later on, we will have a specific value, which is a correlation coefficient that tell us how strong is our data, how correlate does the two data together. Again, that's what the overall chapter 11.1 is. We try to find this correlation between the two variables. We try to see what the relationship is. There any relationship between the two variables? And then 11.2 is we try to find a best line fit, meaning, again, if we were to draw a line, what is the regression between the data, that's what 11.2. Okay, so let's take a look at this thing here. There are a few graphs that we will look a lot in terms of correlation. Is, again, if we have, like I mentioned earlier, from left to right, if you look at A, from left to right, and you see that your data is increasing, right? From left to right, if your data is increasing, we say that this is a positive linear. And again, why is linear? As you can see, it's kind of fill in the straight line, right? If you were to draw a line here, you can see that all your data from left to right start to increase, and it's kind of in a straight line, right? And if you remember, linear in algebra is the slope-intercept form, right? The y equal mx plus b, linear, a straight line, right? So if you go from left to right, this is a negative linear, right? Decreasing, right? And again, for us, and as always, right, the horizontal asymptote will be your x, and the vertical item will be your y item, right? Which is, again, it's depend on your data. And if you see that all of your data scatter out like this, we say that this is a weak linear, meaning it's not in a straight line. It's basically kind of scattered throughout, right? And if it's very scattered, like all over the place, we say there's no linear at all. Okay, and again, this thing non-linear is basically, again, it's still positive, meaning from left to right it's still increased. It's just that it's not in a straight line. It's like there's some curve, right? There's a small curve, or in this case, as you can see, there's a small curve, and that's why we say non-linear. But the negative or positive is basically from left to right. If it's increased, we call it positive, and again, from left to right, if it's decreasing, we call it negative. Or in another sense, this is what they tell you is, if a large value of one variable is associated with a large value of another, then we say that is a positive associate. Meaning, as you can see, the higher the y, or in this case, the higher the x, the higher the y, right? So again, let's say this is 10 and this is 20, the higher the x from 0 to 10, from smaller to largest, and from smallest to largest, which is, again, as you can see from left to right, we have a increase in, which is, this is a positive associate, which is, again, same thing, linear, positive linear associated item, right? And vice versa, if they say one large number, if one large value is associated with one small value, then we say that this is a negative associate, right? Which is, again, this right here, this number, this point right here, this have a smaller x, but big y. Your y is big, but your x is small. Vice versa right here, your x is big, but your y is small. So again, looking at this thing here, we have a decrease in motion. So now we say that this is a negative associate, right? And again, if it's in a straight line, for instance, like this, if it's on a straight line like this, then we just say that this relationship is a linear relationship, okay? Again, a linear relationship meaning if you can draw a straight line and most of the point will be on that item, right? So again, same idea, right? At x increase, y tend to increase, meaning, again, as x get bigger and bigger, y get bigger and bigger, we say that this is positive linear correlation or positive linear associate or positive correlate, okay? And vice versa, if you see this thing here as x increase, as x keep on increase, y decrease, right? So this thing here, we say that this is a negative linear correlation. It's just, again, linear is just basically tell you that it's in a straight line pattern. That's what linear is, right? So again, the idea earlier, they don't say positive. This one here, they don't say linear because it's kind of not really clear to be on one line, right? It's just positive, meaning from left to right is increased, negative from left to right is decreased, okay? So one thing, that's what we do is we use our eye test, right? And our eye test, we basically look at the scatter plot and we basically say, okay, given this scatter plot, we know, using our judgment that it's either positively associate or positive linear correlate or negative linear correlate, right? But sometimes the scatter plot does not help you in the way that sometimes if I change in the increment of the value, then the graph will look a little bit different, right? I can make it smaller and the data will spread out, or I can make the increment bigger, then the data come together with the same data. So sometimes the scatter plot doesn't give you the whole picture, right? It gives you the picture, but sometimes your eye trick you. So what we do is the next thing we have is a correlation coefficient. And the correlation coefficient is basically the number that measure this strength, right? The number that tell us how strong the relationship is. So this is your formula, ladies and gentlemen. Your formula, which is the R, which is, we call this a correlation coefficient. And again, the formula is basically if you have a ordered pairs, which is if you have a bunch of ordered pair of X and Y, and then within the X, you can find the sample mean of the X, and you can find the sample mean of the Y. And within the X, you can find a sample standard deviation for the X, and the sample standard deviation for the Y, right? So if you can do that, if you can find those, then you can just plug this in this formula, and then you find the R. But the thing about this formula is it's very painful. If you have 10 data, meaning you have to do this 10 times. You have to take x1 minus x bar divided by standard deviation, y1 minus y bar divided by standard deviation, and then multiply them together. And then you have to do 10 of them, and then after that, add each of them together, and then multiply to 1 over n minus 1. Okay, so one thing is because we have the technology, I will save the calculation to be another day. Meaning I will make for those of you who like to see the formula, I will make an extra, a different video, and I will post that on Canvas so that you guys can see how the formula work if whoever like math and want to see this formula. But for those of you that not really necessarily into the formula, today, that's what we're going to do is we bypass this formula. So instead of confuse you with the formula, we will go straight to how to calculate this this R, which is this correlation coefficient, okay? But before we do that, let's take a look at what R represents, or how do we interpret R. So the probability R is this. When you calculate R, your answer will only be between -1 and 1. So that's a good thing, is when you calculate R, the answer cannot be bigger than 1 and cannot be smaller than -1. Okay, so again, that's what it tells you. If is later on you will see that the interpret is the bigger the R close to 1 is tell you that it's on a stronger positive linear regression. If the smaller the number R that is close to -1 is tell you that it's a negative correlation. Okay, and one other thing is this: the outlier does make a big difference. So an outlier, if you spot the outlier, your outlier will influence the R a lot. Okay, so that's one thing about statistician is if they can spot the outlier, what they do is they exclude the outlier, and then they just say, okay, the rest of the item, we have this thing here. What can we do with this item? Because sometimes, some error, you might have an outlier. Okay, so but again, that's the idea of the R, or the property of R is the main property is when you calculate R cannot be bigger than 1 and cannot be smaller than -1. Okay. The interpret of R, which is again, when you calculate R, you have to know what R represents, right? Which is again, if you, like I mentioned earlier, if R is positive, we say that they have a positive linear relationship or association. And again, if R is positive and is close to 1, we say that they are strongly positively linear associated between the two data. Okay. And if R is actually equal to 1, which is very hard for you to find two data that is equal to 1. Well, if R is equal to 1, it's basically all of your data is lying exactly on the line. Meaning, again, if you draw one line, all of your data is on that line, and that's where R is equal to 1. And similarly, if R is negative, then we say that they have a negative linear association. And again, if R is close to -1, we say that they are strongly negative linear association between the two data. And if R is exactly at -1, then we say we have a negative line, and all of your data is on that straight line. And I will mention more when we get to that item. And the other thing is, if R is close to 0, meaning if it's 0.12 or 0.07, if it's -0.19 or something like that, when it's close to 0, we say that the linear association is weak or there's none at all, right? So if it's equal to 0, meaning it's all scattered out, you don't have that linear line, okay? So looking at this thing here, that is your goal for 11.1. Your goal for 11.1 is basically this too, which is how can you construct a scatter plot? And from the scatter plot, can we say that do they have a linear relationship between the two? And later on the next thing is we have to calculate or find the correlation coefficient. Okay, so your two objective is basically scatter plot and then correlation coefficient, and then tell your, interpret your data. Does your data, do your two data have a correlation between them? Okay, so let's take a look at this item here. They say that the size of the house and the price of the house in Denver, right? Do we have any correlation between the bigger the house, the bigger the price? Do we know if there's any of that correlation here? So the idea is construct this thing here. So to construct this scatter plot, reminder in chapter 3 we did this before, which is have your calculator, which is in order to construct this scatter plot, we need to hit stat, and then you edit them, which is you type in the first data, your X data, your X value in your L1, and your second data, which is your Y value in L2, which is again, in this case, my X, my independent item is the size of the house, and my Y, the dependent item, is on the price of the house, right? So once you type in L1, L2, you have to tell your calculator, or you have to turn on a feature in your calculator and tell them that I want to plot in a scatter plot. I want you to plot in the statistic. And to do that, you have to hit second Y equal to, and then select number one, just press enter, select a plot, which is a scatter plot, and make sure you turn them on. And once you have that, you press zoom and you go down to option 9, either A or 9, I forgot, zoom stat, and then you choose that and they will give you a scatter plot. So let's take a look at that calculator in hand. So again, let's take a look at this calculator here. So I have, let me clear this. So I have this item, right? So let's say if I have, again, I do an 83. Let me go clear. Make sure, again, if you want to clear this thing here, make sure you hit clear and then enter. Don't delete. If you delete, you delete the whole thing. So again, go up to L2, hit clear and enter, right? So again, let's say if again, this is what I asked you guys to do is hit stat, right? Hit stat and then edit, which is number one, you just press enter, which is now you type in L1, which is for me, L1, let's say, give me 1 second, 25, 21, 25, 55, 27, 35, 28, 46, 30, 28, 30, 49, 31, 98, 31, 98. Again, I have A data. I have A data here. Nope, I'm missing one data. I hate it. 25, 25, 27, 28, 46, 32. Oh, I have 31, 98 and 31, 98. So again, make sure you have A data, which is I have A data here. And then again, my L2, I have 400, 426, 428, 435, 469, 475, 488, 455. Right. So again, make sure that the two data, they all exactly match, right? I have A data here, I have A data here. So after you type in your data, this is what I asked you guys to do is hit second Y equal, which is this item here. And then again, you can either select 1, 2, 3, mostly just select one. And then make sure that you turn it on right here. If it's on off, make sure it's on the on and press enter. And then choose this type of graph, which is this scatter plot right here. So make sure your screen that is on the on button, which is press enter, so it's not on the off item. And then again, everything else, just keep it the same. So once you turn it on, you just click zoom and you go down to option 8, which is zoom stat. Well, option 9, which is zoom stat, and then you click enter. So once you click enter, you should see this on your screen, which is this is your scatter plot. This is the scatter plot that we have, which is your calculator can do the scatter plot for you, which is, again, this is the scatter plot. I just have a 84 picture. But again, looking at this thing here, everybody see that, you know, from the scatter plot, and again, this is the actual scatter plot, which is on Connect Math. They probably give you something like this, and then you have to go in and just, you know, guesstimate a number and put a dot on it for them, right? So again, this is your scatter plot, which is, again, looking at this thing here, it's look like they have a linear, positive linear relationship, right? The smaller the size, the lower the price, right? So looking at this thing here, the bigger the size, the higher the price, right? As the size going up, the price going up, which is from left to right, is increased. So looking at this thing here, they look like they have a positive linear relationship or association or correlation. It's all the same, right? So looking at this thing here, in order to be precise, in order to know if they really have a strong linear correlation, we have to do that correlation coefficient. So let's take a look at this thing here. Well, first of all, question, anybody does not have this scatter plot on your calculator or does not know how to get this scatter plot?
Yeah. What you do after when you put L1 and L2?
You hit second Y equal. You press in second, the second right here, and Y equal. So you hit second Y equal, and this is your screen, and then press enter.
Enter.
And make sure that this thing is on, which is you just tell them that you have some data, turn this thing on.
All right.
And then press enter on the on, and then you press zoom. And then you go down to zoom stat, which is option 9.
All right.
So you have this?
Yeah, I got it.
All right. So again, this is how to construct your scatter plot using your calculator, which is, again, it's just the odd and pair, right? You look at 25, 21, which is 25, 21, somewhere here, 400 here. So you just basically guesstimate that item. But now, the next thing they ask you is find the correlation coefficient, which is correlation coefficient is the number tell you that how strong the item have, how strong correlation do we have, right? So before we can calculate that, we skip the formula. Like I mentioned, the formula is very painful. So again, whoever like math, you will see that video on Canvas once I make it and post it. But again, look at this thing here. Before we can use the calculator to tell us to calculate this thing here, I need you guys to do one thing for me, which is on your calculator, you have to press second on your calculator. This is what you need to do, is you need to turn on the diagnostic. So in order for you to turn on the diagnostic, you need to press second number 0. So again, if you press second 0, this is all of the category that you have. So once you press second 0, scroll all the way down to D. This is in alphabetical order, so scroll all the way down to D, and you should see the diagnostic off and diagnostic on. So if you scroll all the way down to diagnostic on, everybody see your diagnostic on, press enter, and then enter again. So basically you just tell your calculator, I want you to turn on this diagnostic feature that you have in your system, right? So again, press second 0, scroll down to diagnostic on, press enter, and then press enter again, which is, you should see that they have the word done, meaning again, the calculator is ready, that they turn on the feature diagnostic. Once you have that on, now to calculate the item, you press stat, scroll over to calculate, and make sure that you go down to the lin, which is linear regression, A plus BX. Make sure that it's A plus BX. And everybody see number 4. Number 4 is not what we want. Number 4 is linear regression AX plus B. We are not looking for AX plus B. We're looking for A plus BX. Okay. So again, if you scroll down, which is option number 8. Option number 8 is the linear regression A plus BX. So make sure that you choose the A plus BX, because on the next section, 11.2, that is where it's important. Okay, so make sure that you choose option number 8, the linear regression A plus BX. Once you press this, if you have TI-84, if you have TI-84, life is good for you guys, because your X list should have L1, your Y list should have L2, and then everything else just leave it blank. The frequency, leave it blank, and everything else just leave it blank, go all the way down to choose to calculate. If you have TI-83 like the one I have, life is a little bit troublesome. You have to manually type it in, which is you have to hit second number 1 for your L1, comma, second number 2 for your L2. So again, TI-83, you have to manually type in L1 and L2. If you have TI-84, your prop have it for you. And once you type it in, you just press enter. Everything else will be, the calculator will do it. So all that massive calculation that they ask you to do in the formula, your calculation give it to you here, which is again, the A and the B, we'll mention that later. the R, which is again, the R is right here. This is what we're looking for, the R, which is the R is equal to 0.90059. So that is the R that we're looking for. That is the correlation coefficient. So again, looking at this thing here, everybody see that the R is equal to 0.90059, which is again 0.9, which is very close to 1, right? Because 1 is a whole number and this is 0.9. So 0.9 is close to 1. And again, if it's close to 1, we just say that this thing have a, strong positive linear association, right? Between the size of the house and the price of the house. And again, we look at this thing here, we can see that they have positive regression, right? From left to right is increased, they have positive regression, but how strong it is very strong, right? Because it's very close to 1, okay? So again, first of all, question on how to find the R. Everybody see that to find the R, you need to use in this item, which is again, you need to use the linear regression, which is link-reg A plus BX. Make sure it's using A plus BX. Again, the R, if you use the AX plus B is not wrong. It's just that when the next section is will tell you it's wrong when you use the A and the B. But again, make sure that you use option 8 and not an option 4. Question. So everybody see how, yes.
I'm unclear how to get this, the dots, the scatter plot on the calculator.
You using this feature?
Show up.
What's that?
How to get it to come up on the screen.
You hit, did you follow this thing here? You hit, yeah. So you have your data in L1 and L2?
Yes.
Did you hit second Y equal?
Second Y equals, yes.
And then you turn on your item?
At plot 1, right?
Yes.
Yes, it's on.
And then you press zoom, which is right here.
Okay, then I press zoom.
And then you scroll down to zoom stat, which is number 9.
Oh, okay. I didn't have that written down. Zoom stat. Okay. Oh, okay. Now I see it. Thank you.
All right. So again, that is right here, right? This the item I have is right here. But again, that is how you scatter. But again, the most of the Connect Math, when they ask you to do the scatter plot, is they give you this thing here, and then you have to go in and just basically, this is the odd and pair, right? 25, 21, you guesstimate 25, 21, you go to 400, right? 25, 25, you go to 426, right? So you have to manually do it on your Connect Math. I just show you that your calculator can do it, but most of the time, if they ask you to construct the scatter plot, you have to manually go in there and put in the actual dot, right? But again, that's what we have. But again, the calculation, the R, question of how to find the R here. So everybody got the R. And then, ladies and gentlemen, that is what we have, or that's the only thing that we do in 11.1, which is how to calculate this R, right? So your calculator can calculate the R for you, easily, right? I try to find another word, but it's in my head. I cannot spit it out. But anyway, let's take a look at another example, right? Let's take a look at another example here, which is, let's say that a student conduct a study to determine whether there is a linear relationship between the number of hours student exercise each week and the student grade point average. The data are shown in the table below. Find the scatter plot and then describe the correlation, or basically find your correlation coefficient. So if we have this data, which is again your data, they give you the X, which is your hour of exercise, 12 hour a week, 3 hour, 0, that's me, right? 6 hour, 10 hour, 2, and so on, right? And then the GPA, which is again the Y value. So again, looking at this thing here, to do this thing here, we have to, again, the first thing we have is we need to enter in your data. You have to enter in your data, which is your L1 and L2. So again, let me enter in my data. here. So my L1, which is I have to enter in the 12, the 3, the 0, the 6, the 10, the 2, the 18, the 14, the 15, the 5, right? And then I have to enter in my L2, which is my L2. I have a 3.6, the 4.0, the 3.9, the 2.5, the 2.4, the 2.2, 3.7, 3.0, 1.8, 3.1. So again, make sure that your data are lined up. So I know that my data line up, so I probably did not miss anything. If I happen to miss anything, I probably missed for both of them, so I'm good to go, right? So again, once you turn it on, you don't need to turn on every time. You just go to, if you want to graph, scatter, plot this thing here, you just go down to this zoom, you just click zoom and zoom stat, right? So if you click on this thing here, you will see that that is your scatter plot, which is your scatter plot. If you look at that scatter plot, is very scatter, right? Looking at this thing here, we cannot really say that this have a positive, we cannot say that this is really have a positive linear, right? It's kind of just scatter all over place, which is, this is probably non-linear, right? You know, it's very scattered out. We don't have any relationship in terms of positively or negatively, right? They all just scattered throughout your item. Okay, so once you have this thing here, which is, again, if you have your calculator, and if they ask you for the correlation coefficient, reminder, correlation coefficient, you go to stat and you go to calculate, which is the second item right here, and you go down to number 8, which is the link rec A plus BX. Make sure it's A plus BX. And if you press that, again, because of my calculator, I have to type L1, comma, L2. I have to manually, because of 83, I have to manually type it in. And as you can see, if you type it in, your R is equal to negative 0.163. Meaning, again, looking at this thing here, we can see that, you know, because the R is negative, we know that they have a negative associate, right? Because the R is negative 0.16, we see that this thing here have a more of a negative trend than a positive trend, right? But everybody see that because of a negative 16 is close to 0, because of a negative 0.15 is close, or 16 close to 0, we say that they have a weak linear associate, right? We know that they have a negative trend or negative associate, meaning, again, it's more of a negative 4 than a positive 4, right? Because the bigger the X, the smaller the Y in the sense, but it's not that strong, right? But again, because it's close to 0, we say that they have a weak item, right? So again, look at this thing here, weak or non-linear at all, right? So again, looking at this thing here, question in terms of how to find the scatter plot or how to find this R value. And again, you know, without using the formula, your calculator, you know, can do that massive formula out. And this is all that we need is the R, which is the correlation coefficient. So question of how to find this correlation coefficient, because the main question in 11.1 is they ask you what is the correlation coefficient, and then can you interpret this correlation coefficient. This thing will be a negative association, and they have a weak linear, which is all scattered out. Question.
I have a question. Like for the homework, it says construct a scatter plot. So the scatter plot on the homework is numbered. On our calculator, it's not. So you're just basically just guessing where the dots are actually going.
Well, you have to go with the number they give you, right? So on the homework, they will give you the number line. Basically, this is the number line here. Basically, this thing go probably 5, 10, 15. No, probably 3, 6 something in terms that this is the 12, right? So again, I'm sorry. The Y is the 1, 2, 3, 4, right? So this is 1, 2, 3, 4 up here. So this is your X, which is your X is your number line, which is, again, they probably go by 1, 1, 2, 3, 4, all the way to 12. So if they ask you to plot, which is, again, you go to number 12 on your X, and you go to number 4, which is, that's where the 4 point, right? The 12 have the, not the 4, 12, 3.6. So you go 12 and 3.6 and you put a dot, right? And this is the 3. So you go 1, 2, 3 and 4, which is right here. That's where the 3, the order pair is this, right? The order pair is 12, comma, 3.6, 3, comma, 4.0, which is 3. You go 1, 2, 3, and then the 4.0 is right here, right? And the 0 is 3.9, the 0, 3.9 is right here. So on your homework or on your Connect Math, they give you that order pair, or basically this is the order pair. Then you have to go to the number, and then you go to the correlate of your Y, and you put in the dot. Is that making sense?
Yes, thank you.
Yeah, so again, they will have, for this thing here, pretty much because of the calculator, they don't label the number for you, right? Each of this dot is go by 1 unit. This is 0, this is 1, 2, 3, 4, 5, all the way to 12. And this is 1 is right here, 2, 3, and 4 is right here. So that's where, it doesn't label the number in this calculator. But again, you just want, for this one here, I just want you to have an idea of how your scatter plot look like. This number is more important because this number tells us, do we have a positive or a negative? And do we have a strong linear or a weak linear, which is, again, the closer to 0, the weaker we get, right? The closer to -1 or closer to +1, the stronger we get. And if you look at this thing here, you can see that this 2 item should not have any correlation between, right? How can you exercise more and improve your GPA, right? The number of hour exercise should not influence your GPA, right? The number of studying might be, right? The bigger the number of studying, the better the GPA might be it. But again, they might have the correlation of that, but exercise should not improve the GPA, right? So, and again, if you look at this 2 data, you can see that this 2 data does not, rarely they will have any correlation. And that's what we have right here, is they have a weak association, because the 2 doesn't have, one doesn't improve the other one, So again, so for information purpose, your correlation is not causation, meaning you changing one item does not necessarily change the other item. The same thing as our previous example, right? The number of exercise probably will not improve your GPA. This thing here, they say that, again, if you read this thing here, they saw that the suicide of the student tend to get a higher test on the vocabulary, right? And the smaller size of the suicide, the lower grade on the test. Well, does the suicide influence the test grade? Not really, right? So again, sometimes the 2 data that you try to compare might not influence one another. So, changing one thing here does not change in the other one. This doesn't have that cause and effect. Sometimes your data does not have that item cause and effect, okay? So again, it's depend on your data in the sense of that. But again, our goal in 11.1 is basically, can we determine if they have a linear association? And again, the closer the number to 1, the stronger we get, right? The closer to 0, the weaker we get. Okay, so that's the idea. And again, most of the time they will ask you to find that correlation coefficient, which is the R value. So question with this 11.1 here, how to find the correlation coefficient, or how to use your calculator to scatter plot. All right, if you don't have question, let's take a look at 11.2. So again, 11.2 is nothing new. 11.2, like I mentioned, we are dealing with a regression or a least square regression line. So now, once we have our correlation, once we know if we have a correlation, now we want to know how to predict the future value. How can I come up with if I have this model, right? We basically, this is our goal, is we want to find this model, and we can use this model to predict a future value. So the model that we're using is a least square regression line. The least square regression line is basically tell you this, ladies and gentlemen. If we were to put a line, on your item, right? If you were to put a line, how can we put a line that fit the item the most, right? Meaning, again, if I put this line here, I can put the straight line anywhere on this thing here because I can see that this is a positive, this is the scatter plot from the previous problem. We can see that they have a strong positive linear association. But now I can put the line anywhere, but our goal is wherever the line we put is have to be the best fitted line. Meaning, whatever the line we put, the distance among all of your points to that line have to be the minimum, have to be the smallest. Meaning, if I draw a line here, everybody see that each point is not on the line. We try to fit as many points as possible, but because there are many different variations, so we try to minimize the distance from the point to the line. So as long as the distance, the average difference from the point to the line is the smallest, we call that is the least square regression line. So if you can see right here, over here, I draw this line. We know that it's a positive line, but if I draw this thing here, negative curve, the distance between each of the point to the line is very large, right? The average of this thing here will not be smaller than the average difference of this thing here, right? So again, that is what your least square regression line do, is we try to find the best fitted line, which is most of the time you see that the best fitted line is the same as the least square regression line. It's basically you try to draw a line that fit the most point on it, okay? And if it's not on it, then the distance between all of the point is the smallest distance, okay? So again, that's the idea of the least square regression. Our goal is won't find the least square regression line. Our goal is how to find the model, which is the formula that fit that model, the formula, the y equal mx plus b item. So this is your formula. This is your model that we fit this item here, which is, again, our model is this, which is the y. Again, the book, the author using y hat, which is the predicted item, equal to b sub 0, which is, this is your y-intercept, plus b sub 1x, okay? So again, that is why I asked you, when you use your calculator, we're using our calculator. Remember, our feature in our calculator is the a plus bx. So again, that's why we have to use the a plus bx and not the bx plus a. I mean, the ax plus b. So that's why this is what we have is, for us, the a is the y-intercept and the b is the slope. So anything in front of the x is the slope. So to find this equation, to find this model, this is our item here. Your y will never change and your x will never change. Your goal is you need to find that a and you need to find a b to plug into this model. And again, this is the same as your slope-intercept form. Whoever remembers slope-intercept form is y equal to mx plus b. It's the same idea here. That is why our, again, mx, which is anything in front of the x, is the slope, and the constant is your y-intercept, okay? And we're using this thing here, which is, again, that is our formula. And let's go back to this problem here. Let's go back to this problem, which is, this is the one thing, or the one of the two things that they will ask you to do is, can you come up with the regression equation line, right? compute the least square regression line for predicting the sale price from the size of the house, which is, again, reminder that this is your independent item and the price is the dependent item. So if you do this thing here, which is we do the same thing what we have before, right? So we have this line, we want to find this equation, which is to find this equation, ladies and gentlemen, this is all you need to do is the same as before, which is you press stat, calculate, and scroll down to the option number 8, which is the Linggrad A plus BX. Make sure it's A plus BX. If you do the AX plus B, your A and B swap the position and it will be wrong when you type it in. So make sure that it's Linggrad A plus BX and then your L1 and L2. So if you do that, this is your outcome. This is the same outcome we had before. This is the outcome that we had before. Once you put the Linggrad A plus BX, we have the all last time. Now the only thing that we need is we need the A and we need the B, which is the A and the B is the same feature you have from your item we did last time, which is now the only thing we do is we take this thing here, we extract the A and we put it here, which is the A. Instead of putting A, we put 160.1939. And instead of put the B, we just put 0.0992x, which is, this is my model, this is my equation of this least square regression line. Like I mentioned, the y hat, which is the predicted value, and the x will not change. Your y and your x will not change. This is your model. This is your equation. This is what they want you to have. And how do we find this? We just basically extract it from this feature here. Okay. So again, if you look at, if you try to type it in, if you try to type in, probably your calculator does not have this data. You have to, because we did the other problem, your calculator does not have this data. You have to go in and basically re-enter your data in. Okay. So if you re-enter your data in, everybody see that, let me, give me 1 second. Let me do the TI-84. So whoever have 84 that you say, oh, I don't see what you see. If you have 84, again, 25, 21, 25, 55, 27, 35, 28, 46, 28, 46, 30, 28, 30, 49, 31, 98, and 31, 98. And I have 400, 426, 428, 435, 469, 475, 488, and 455. So again, if you have this data, if you type in your data, this is what we do. We go over to calculate and we go to option number 8. Make sure it's option number 8 and not option number 4. And then you just press this. And like I mentioned, for TI-84 user, life is good because your X, they put in L1 for you. Your Y, they put in L2 for you. Everything else, just put it blank. And then you just go into your calculate. Okay. So again, TI-81, you have to manually type in your L1, comma L2. So if you have this on your calculator, ladies and gentlemen, if you have this in your calculator, again, this is the two things we needed, which is the A and the B. Everybody see that I don't have the all square and the all. If you have this screen as I have, the reason is you did not turn on the diagnostic test. Okay, that's the only reason is if you did not turn on the diagnostic, which is you have to hit the second 0 and go all the way down to diagnostic on. So again, if you just have the A and the B and without the all square and the all, is basically because you did not turn it on. So you have to turn it on to in order for you to find the all and the all square. But again, looking at this thing here, looking at this thing here, question on how to find the A, the B, and the R, right? So again, if you have this thing here, which is the same outcome or is the same item I have, which is the A is the 160.19 and the B is 0.0992. So again, question in terms of how.
Where does the R come from again?
The R is your regression, not regression, your correlation coefficient. That is in 11.1. That's what we did last time.
Okay.
Right. Again, remember your R tell you how strong your linear item is, right? The R right here is 0.9005, which is, again, we say that this have a very strong positive linear relationship, right? Because it's from left to right is increasing and it's kind of on the path of the straight line, right? That's what the R is in 11.1. But 11.2, now we only need in the A and the B, which is the A and the B. That's where you take it out and put it in here. And this will become your equation, okay? So question, anybody does not have this output in your calculator or does not see where my equation of a line come from? Equation, again, this is what they ask you is come up with the equation of the linear regression least square regression line. So again, least square regression line, which is this is the equation that we want or they want. And again, the reason why we use the A plus BX is because that this is the form that they want. They want the y-intercept plus the slope times the x. Okay.
Somebody's asking how you put the L1 and the L2 into the calculator.
For TI-81, I mean,
Not
80.
sure, they typed it in the chat.
Again, you have to hit second for your L1 and L2. If you need to type in L1 and L2, let me go back. If you need to type L1 and L2 in, you have to hit second number 1. You have to, again, in order to type L1, you have to hit second number 1, which is the blue item, and then comma second number 2 for L2. So again, to type L1 and L2, you have to hit second L1, which is number 1, and then the comma is right here, and then you have to hit second number 2 for L2. Okay, so that's how you type in L1 and L2 in your calculator.
Okay, thank you. I was just asking because I tried it before and for some reason the comma wasn't showing up on the screen.
You have to type.
But it's working now.
Yeah. All right. So if you, so once we have the equation, now like I mentioned earlier, the equation is basically we using this equation that we just found so that we can predict the future value, or we can predict a value based on our model. Okay, so looking at this thing here, they basically tell you that once you find that equation, somebody do the end notation. Again, this is what they tell you is once we have this equation, can you predict the selling price of the house? Can you predict the selling price of the house if we have this size, right? So they basically tell you is, I want to know how much does the house cost if the house is 2,800 square feet, right? So looking at this thing here, all you need to do is once you have the equation, all you need to do is because the size of the house is my X value, all I need to do is plug that number, the 2,800 into my X, which is everything is the same, which is my formula is 160.1939 plus 0.0992x. So all I need to do is plug in for the X value, which is, remember, your X is your independent variable. Your X is your independent variable. And again, your Y is your dependent variable, which is in this case, this is what we have is we plug in the X, the independent variable, and then we predict the Y, which is, everybody see that 0.0992 times 2,800 will give me 2776. And if I add them together, I have 437.9. Because they asked me to route to the whole number, then again, the predicted value is if the house is 2,800 square feet, then the price should be $438,000, right? Estimately or predictedly, that's what we have. So again, if you look at this thing here, this is what I have is, again, my purple line here, that's the equation of the line that I come up with. That is the best fitted line, right? I guess this line that is best fit because the distance of each point is small. So the 28 is right here. Basically, they tell you if we have the 2,800 square feet, what will be the price? Well, the price will be somewhere around this range right here, which is again 438,000, right? It's not on the 440,000. It's a little bit below. So again, that's what we have. Same thing go if they say if we have a 3,000 square feet, what will be the predicted point? Well, not point, predicted price. Then again, we go up here, which is if you have a 3,000 square feet, the predicted price will probably be 457 or 458,000 between that, because it's not 460, so it's below. But again, the range here is basically is 20,000, right? So again, it's probably around 457 or 458. And again, to be exact, all you need to do is take the 3,000 and plug in the place of the X, right? And then you just type in this formula, which is again, that is the point, or that's the purpose of this formula, ladies and gentlemen, or this model, or this regression equation line, right? Because this equation basically give us an idea of the predicted value, meaning we can predict the future value for say, right? And that's what a lot of stock broker do, right? They found a trend and they have all this model and they say, okay, if this happened, the price of stock gonna be like this. Okay, go ahead, buy or sell, right? So again, this is what we do in terms of regression, the item that we have here. So question, first of all, with how I come up with this equation, and what is the purpose or what is the use of this equation that we came up with? And that's all we do in 11.2, ladies and gentlemen, is how can we come up with this equation? And for you guys, which is your calculator, can give you the A value and give you the B value. All you need to do is substitute the A here and the B here, and then again, the X and the Y will stay the same, okay? So let's take a look at the interpretation of the X and the Y item, or the slope and the item. So again, the Y hat, which is again, the Y hat is just basically the predicted value, which is the estimate of what the outcome will be, right? So again, basically you plug in your X, whatever the X they give you, you plug in the X, and then you plug into the equation, and whatever the answer come out, that is just the estimate of the average, right? The estimate what is the number will be. Okay, your y-intercept, your b sub 0, or in our case, the A number, you rarely have to interpret this thing here. The y-intercept, if you remember in algebra, where is the y-intercept? Well, the y-intercept is when the x is equal to 0 and the line crosses the y. Right? So they tell you that unless your X data have a positive number and a negative number, unless you have those two numbers, and then that is when your line will cross your y-intercept. But most of the time, your data won't have that, right? Your data, if you compare the house size with the price, how can the size of the house be 0, right? I mean, if the size of the house is 0, meaning you don't have a house at all, right? So again, in the sense, you rarely have to, if the size of the house is 0, you plug into the previous problem, it will be 160,000, meaning you can say, well, the land itself is 160,000. But basically, again, you rarely have to interpret the y-intercept because most of your data won't have both a positive and negative item. The other one is the unique one, the slope. The slope is the unique thing here is they tell you that if we have the slope, which is your slope is your b, the number in front of the x. So this is what they tell you, that if the 2 point on the line is different by 1, or a matter of fact, if it's different by whatever the item is, then all you need to do to find the difference, between the y, if they give you the difference between the x, all you need to do is take that difference, times the slope, times the p. So whatever the difference is, you time, again, this d item is the difference between the value. Take that difference and multiply to the slope. You will see that you can predict, without using the formula, you can predict what will be the difference between the y item. Okay, so again, looking at this thing here, all this wording is a little bit difficult to understand, but think about this thing here. Remember, my x is the sizes of the house, right? So if they tell you that 2 houses different in size by 150 square feet, what would be my difference in price if the difference in the house is 150 feet, right? So they tell you that if we know the difference in 1 unit, which is the difference in the x, then all we need to do is take this difference and multiply to the slope, which is whatever the number in front of the x is, which is 0.0992. If you take that and you multiply, you can see that the difference is $14,900. So again, 14,900 in terms of the differences, right? So if you don't, this is just a shortcut, right? If you want to do the long way, instead of thinking of this way, if you do the long way, you can, if you remember what we did earlier was the 2,800, right? So do you agree that if I have a house that 2,950, which is 2,800 plus 150, we have 2,950, right? So if you want to, you can plug in the 2,950 square feet, plug into your formula, find out whatever the price is, and you take that price and minus the previous price, you can see that the difference is the same. So they just basically, they tell you that instead of plugging into the formula and find the final price and then find the difference between the two final price, well, we can just skip that step and jump into, take the slope and multiply to whatever that difference is. Okay, that's all they tell you to do, is that take whatever the difference is and multiply to the slope, and then you can predict the other item. Okay, so again, one thing is, this is just, there are many ways, because this thing here is basically algebra. There are many ways to do or find the difference, but one easy way that they tell you is take the slope and multiply, and then you see the other one. But again, the one most important thing that I want you guys to take, or that you will do a lot in 11.2 is, ladies and gentlemen, is you need to find the equation of the line. You need to find that least square regression line. That's what they ask you to do a lot, which is to find that least square regression line. You have to find, plug in L1, L2, and then extract out that A and that B once you do the Linggrad A plus BX. Once you find that equation of the line, then they will tell you that I have something, can you predict the other one, right? So again, that's what you would do a lot in 11.